Hello, everyone. This is Mr. McClung's Mathematical Machinations, and I am Mr. McClung. Today, we are going to go over vertical reflections of exponential functions, and as a bonus, at the end, we're going to also go over a combination of a vertical reflection and a horizontal reflection, so you can see both on happening together. We already did one of these on horizontal reflections. And so this will make a good one to put together with the other one. In case you haven't seen the other one, be sure to link that in the description. So here we go. So we have here an exponential function, f of x equals 3 times 2 to the x, and this is the graph of that. And so notice it has an initial value of 3, and we can see that represented as the y-intercept here. And it has a base of 2, meaning every time the x value increases by 1, we're going to multiply that by that base. We also have a table here that I'm going to use to help demonstrate what's going on. But quickly, let's see what makes this reflect vertically. Okay, so if you think about vertical, you should think about y values. Any positive y values means those points will be above the x-axis. Any negative y values, and those points will end up below the x-axis. So if we can change all of the y values from to the opposite of what they are, no matter if they're positive or negative, then we will reflect every point to the other side of the x-axis. In other words, reflect it vertically. So there's a very quick way of doing that, and I'm going to have you look at this first. Notice we have, here are some x values, here are the y values. Notice all the y values are positive. Notice f of x, it says f of x here. F of x is the same thing as the y values. So when we see this here, this really says y equals this function. So if we put a negative in front, it changes all those y values to the opposite of what they used to be, and it reflects this over the x-axis. Notice it did in fact reflect it, and notice all the y values change from positive to negative. Let me change it again. Focus on these values here, and you'll see they stay the same. I'm going to change it back to positive. They'll stay the same, except for the sign will become positive on all of them. Oh, so that's all it takes to reflect an exponential function vertically. It's positive, put a negative in front, it changes everything to the opposite of what it used to be. And that's it. So we can go ahead and now do a couple of demonstrations with some marble slides. So if we look over here, we can see we have this original blue one. We can see these stars down here, and you can see that the point 0, 4, if we reflect it, it'll hit right here at 0, -4. So again, how do we change all of the y values so they're the opposite, and we end up, in this case, below, all the points end up below the x-axis? Change the function so it's negative in front of the coefficient. There we go. So we change that to negative, and it reflected over here. And notice we can now launch and capture all of those stars. Okay. All right. Hopefully you can see this launch button up here. I realize that it's possible my video is covering that. I don't know until I'll look at the recording, but hopefully you can see there's a launch button in the upper right here. If you can't see it, there's one there, and I'm just clicking launch, and it launches the marbles. Boom, I just did it again. All right, so there's one example. Let's do a second example. Again, this time, once again, all of these, we have our function here. Here it is graphed. And once again, we can see this time we have 0, 5. So the initial value is 5. We have 0, 5 for the y-intercept. And we can see the y-intercept should be changed to 0, -5. So again, we can reflect it by putting a negative in front of the function. And again, I'm going to hit launch and capture all the stars. And then the bonus one that I talked about. So first of all, if you look down here, you can see that 0, 4 does reflect down to 0, -4, but the curve goes like this. So we're actually going to have to reflect it twice. So I'm going to do the reflection we've just been focusing on and change all of the y values to negative. Notice we don't capture this. But if I were to reflect this horizontally over the y-axis instead, that's a matter of changing the x values. And as we discovered in the other video, changing the x values we can do in a similar way, but this time we focus on the actual x right here. And we just multiply it by -1. In other words, make it negative, and we will reflect again. this time horizontally over the y-axis, and now we'll be able to hit launch and capture all the stars. So that's how we did two reflections on the same function. We did a vertical reflection here by putting a negative in front of the function, and we did a horizontal reflection by putting a negative in front of the x. Again, that negative in front of the x, it's the same idea. We're trying to get all the x values to be the opposite of what they used to be. And so the way that works here is, I would input uh, any positive values that I input will then become negative in the exponent and switch to the opposite of what they used to be. All right, as far as the exponent is concerned. All right, that's it for today. I hope you enjoyed that video. Be sure to like and subscribe if you would like to see some more of these videos, and you can always search for, Mr. McClung and for any type of topic you're looking for, and you can look in my playlist for other topics too to see if they might fit what you need. All right, have a great one, everybody.